This is lesson 1.3 on factors and arrays. Before watching the video, please make sure that you have a graph sheet of paper in front of you, a straight edge or a ruler, a pencil, and some different colored pens or highlighters. If you need to pause the recording to retrieve those items, please do that now. Now I'm going to continue on if you're ready to continue. So please jot down what you see on the page. Anything that I have written in black, you should be using pencil for. So please write down today's date at the top left-hand corner of the page, as well as the title underlined with the ruler, 1.3 Factors and Arrays. At this point, you would have watched the Brain Pop video on factoring. And remember, the previous lesson to this was on divisibility rules. So one of the goals of this lesson is for you to be able to connect your knowledge and use your knowledge of divisibility rules to find the factors of a number. Now, let's begin with some basic definitions. So jot these down and think about these definitions on your own before we go over them. So let's talk about a factor, actually. Let's make this singular. So think to yourself, what operation involves the use of factors? So when we think about a factor, we think about a number multiplied by another number to get a product. I'm just going to highlight factor as well. Okay, factor again is a number multiplied by another number to get a product. So for example, if we think about the factors of 24, two factors of 24 are 6 and 4, which will give you the product of 24. So just circle these two here. 6 and 4 are factors of 24, and just a reminder that 24 is the product because it's the answer to a multiplication question. Now, so that's our basic knowledge now. So at this point, you'll be asked questions such as finding the factors of numbers. So let's start off with that. And let's try to connect our knowledge of divisibility rules in trying to find the factors of a number. So let's start off with a slightly larger number. Let's say find the factors of 100. So what you need to do is list all the factors of 100. So I'm going to show you one method in listing all the factors. I like this method because it helps you organize it in terms of its arrays, which I'll get into in a second. Also, it's a systematic way of making sure that you're getting all the factors of the number. And so what we'll do is we'll do a factor rainbow. Now, what I like to start off with when you're listing the factors of any number is that you know all numbers will have 1 and itself as factors. Now note I've listed 1 and 100 far apart from each other because I'm anticipating lots of numbers in between. I'm going to match up 1 and 100 there because I know that 1 times 100 will give me 100. Now you go up numerically. Using your divisibility rules, think to yourself, now, is 100 divisible by 2? Yes, it is, because it ends in a 0. So you know that 2, and think to yourself, 2 times what equals 100? Well, I like to think of quarters, I like to think of money or fractions, you know that, or percents, so 2 times 50 will give you 100. Now note I'm starting to list it by commas because we list it in terms of the factors of the number. I'm going to take a different colored pen and join up 2 and 50 because I know that that's one array of 100. Now, going back to divisibility rules down here, okay, is 3 divisible by 100? Think to yourself, can 3 can 100 be divisible by, is 100 divisible by 3? The answer is no. And think to yourself, remember that the sum of the digits does not add up to a multiple of 3. So we don't have to worry about 3. Is 4 divisible by 100? I mean, is 100 divisible by 4? Yes, it is. You should know that from your background knowledge of quarters and percents and fractions. So know that 4 is one factor of 100. So then I'm going to do 4, comma, 25. Okay, and I'm going to join that up with another color here. Okay, so we've got 4 times 25. We know it's divisible by 4. Okay, let's move up here. So is 5 divisible? Is 5 a factor of 100? Well, think about the divisibility rule for 5. The last digit has to be ending in a 5 or a 0. So yes, it is a factor. So I'm going to have 5, comma, so 5 times what equals 100? So you think to yourself, what is 100 divided by 5? You know it's going to be 5 and 20. Okay, so I'm going to join that up using green. Now, I'm still going down the factors here, and I'm still going up numerically. So up from 5 is 6. Is 6 a factor of 100? Well, remember the divisibility rule for 6 says that a number has to be divisible by 2 and 3. So does this satisfy the condition for 6? No, it doesn't, because the number is not divisible by 3, only by 2. And then I think about 7, and I think about 8. I know those aren't probably possibilities, but there's probably one more that I'm missing. The last one has to be 10. Okay, so is it divisible by 10? Yes, because the last digit is a 0. So it's actually going to be 10, comma 10. Now you don't have to list the number by itself twice, but I'm going to anyways, just to illustrate that we've reached the middle. You know you've reached the middle or the end of your factors if there are no more numbers in between. So I know that numbers like 11 and 12 and 13, etc., up to 20 are not factors of 100. So now I've stopped. And so now you've listed the factors of 100 right here. Okay. Now, let's think about the next concept, which is called arrays. So when we think about arrays, it's a little bit easier to deal with a smaller number, okay? So what we'll do is we'll do another question where you're finding the factors of a number. But this time what I want you to do is I want you to pause the recording, do the factor rainbow yourself, and then replay the recording and review your answers with me. So I'm going to continue here. So now your second question is going to be, find the factors of 28. So again, pause the recording, set up your factor rainbow like in the previous example for 100, and then replay the recording once you think you're finished. I'm going to continue. So I'm going to follow the same process as before, but I'm going to go a little bit faster this time and apply the rules of divisibility in my head. So again, you start off with 1 and itself. So 1 times 28 will give you 28. I'm going to connect that using an array there. I know that it has to be divisible by 2 because it ends in an even number. So it's going to be 2 times 14. That will give me 28 here. Okay. Thinking about my divisibility rule for 3, well, 2 plus 8 will give me 10, so therefore 10 is not a multiple of 3, so 3 is not a factor of 28. I think about 4, I think about my multiplication table, so 4 times 7 will give me 28, and then I connect it like that. So, are there any other factors of 28? Is 5 a factor of 28? Well, it doesn't end in a 5 or 0, so we can eliminate 5. Is 6 a factor of 28? No, because it's not divisible by 2 and 3. It's only divisible by 2. I think about my other numbers. Now, by this time I look, well, there's nothing bigger than 7, or sorry, nothing smaller or in between 4 and 7 that's a factor of 28. So I've hit all the factors. Okay, so this time there's only 3 sets of factors in this case. Now, think about what an array is. Now, arrays you might have done in previous grades where you would have had counters or marbles to arrange the arrays of numbers. Now, an array, when we're talking about multiplication, so you can jot this definition down, an array is an arrangement of numbers in columns and rows. Now, you wouldn't have repeat arrays. So in this case, the arrays of 28 are 1 by 28, 2 by 14, and 4 by 7. Okay, so notice that we've grouped them into pairs. So those are the arrays of 28. So therefore we say there are 3 arrays or 3 groups of arrays of 28 because each pair of factors makes up an array. And usually in the past, if you're asked to draw or sketch the arrays, so for example, sketch an array of 28, then I would maybe let's pick 4 by 7, for example. So you can use dots or circles. So, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So we've got 4, 8, 12, 16, 20, 24, 28. So this array is a 4 by 7. Okay? And that is the lesson on factoring. So remember, one of the ideas to come out of this lesson is to connect it to your knowledge of divisibility rules.